The single slit pattern is weird, the proof is weird, and if you've become comfortable with double slits and gratings, now this is different, which adds to the weirdness. So hopefully by doing a few examples, we can kind of figure out the weirdness of it and learn to work with it. What's different about a single slit is when we see the pattern, it's got that bright spot in the middle that's really bright and wider. Then on either side of it, I can't shade very well on the iPad, but on either side of it, then they're evenly spaced, but they're not as bright. I have a tough time showing brightness on the iPad screen, but the middle one, which is called the central max, is the brightest and the widest. Then after that, those other maximums, they tail off in brightness due to that canceling. They fade to dark, come back to a bright spot that's not quite as bright, fade to dark, come back to a bright spot. Outside of the central maximum, the distance from dark to dark is the same as bright to bright, like it was before. What's different is if we measure from the central maximum, from a bright to dark, that spacing of this special bright to dark is the same as the other spacings of dark to dark and bright to bright. So those three little lines I've drawn, this kind of corresponds with n equals 1, this corresponds with n equals 1, this corresponds with n equals 1. If I had drawn this more carefully, all of those spacings should be the same. Dark to dark outside the central maximum is the same as bright to bright outside the central maximum, which is the same as bright to dark when we include the central maximum. A common question is this first one: what if we measure from the dark on one side of the central maximum all the way to the dark on the other side? Probably the easiest way to do that is if we're measuring across dark to dark, across that special dark, that corresponds to an n equals 2. N equals 1 would get us from the middle of the central maximum to the dark, and then another n equals 1 would get us to the dark on the other side. So n equals 2. Then it's kind of like questions we've done before. The lambda we convert the same way. The L is the same. And the way this question's worded, we don't know the W. And back here, actually I goofed, we did know the Y value. The dark to dark was 3 centimeters, so this would be 0.03 meters. Now it turns into a plug and chug. I've already done the thinking, so I know that on the right hand side of the equation, the n lambda side, the n that I'm going to put in there is 2. And then it's just a matter of plugging the other numbers in. I don't know W, I know Y is 0.03, I know that L equals 2. Sorry, I got a little bit messy there. If I rearrange and solve, multiply by the 2, divide by the 0.03 and crunch it all out, I get the number 6.7 times 10 to the negative 5 in meters. So in a way it's similar to doubles and gratings, just we have to do a little bit of thinking because that